Hi guys. Probably been wondering why I haven't been putting out videos lately. I spent the last couple of weeks in the hospital. I won't bore you with the details, but let's just say that I had plenty of time to look at the ceiling and think about videos to make on YouTube. So what I did is before I got sick, I put in an order to Enco. They have 30% sale, and got some new tooling I want to show you, and some other stuff that I do around the shop here. Got a new sign bar. I'll show you how to play around with that. I got some new inserts. I did some bandsaw mods about 3 weeks ago. Finished up the shop press plumbing. Got some pretty cool uses for neo-magnets around the shop that I'll share with you. I want to talk a little bit about personal protective equipment and abrasives and lubricants. So that's on the list. Probably won't all make it into this one, but we'll get as much in as we can. So stand by and I'll show you some stuff here. Okay, so anybody who has one of these 4x6 bandsaws knows that there's a few things that you can do to them to make them work a little better. And one of them is to put an auxiliary table on. Basically just simple piece of angle iron. What this allows you to do is use clamps here to put stuff on here that you can't get in the vise. Eventually what I'm going to do is probably drill a couple tapped holes in here for some toe clamps, but right now I'm just using cant twists on here and it seems to work good. Second thing I did was put on this auxiliary fence here, and what this does is, this part of it swivels like you've all seen before, but if you got something that's really short, you got to pack it in back here. So what I did is welded on a 1/2-13 nut and tapped it in there. So now if you got something short, you can still clamp it in there. And I cut this thread a little sloppy because I just want to be able to turn it. I don't want to need a wrench or anything. So I think I'm going to do one more mod to this, and that's to make this table ride on the part that moves. That way I won't have to have this wrench down here to bolt it on when I want to use it in a vertical mode. But yeah, there's a couple of little things you can do to your saw to make it a little more productive for you. I'd originally pinned this here at 90 degrees. I put some pins in there years and years ago that hold the back part of the vise at 90. If I want to turn it for whatever reason, like if I want to cut a 45 and it's big, I can just pull these two pins out, loosen this bolt, and I'll swing the whole thing around. So that's it for the saw mods. Okay, so what I got here is that is a particulate filter. Inside of it there's a sintered bronze element, a couple of elbows, and then I go into the switch, and then this goes up to the motor. And look, Ma, no hands. So if you watched my video on broaching that pulley, you would have seen that I needed 3 hands. Well, now I have 2 hands and a foot, so I could have done that a lot easier. But anyways, yeah, so aside from a few little clamping aesthetics, which I have to either make or find. The press is done. So yeah, if you happen to have all this stuff set up and you don't like that stupid hand switch, hook it up to the floor and make a pedal out of it. I plumb this up this way so that, you know, occasionally I could dump some oil down in there. If I hardwired it into my compressor, probably eventually would have a problem. So what I do is I just drag the air line over, and you know, just before I hook it up, I put a few drops of compressor oil down there, and seems to keep everybody happy. So that worked out pretty well, actually. I'm quite happy with the way this press turned out. Eventually I may actually think about putting a hydraulic pressure gauge on here. I gotta look and see. I think this port right here, backlighting's lousy, but there you go. There's a port right here. I think it's a test port, and I'm gonna see about maybe hooking up a pressure gauge to this thing so I can see how much tonnage I'm putting down, because right now it's kind of hard to tell. I mean, this thing, it's a reciprocating pump type thing, so it's almost like an impact gun. You really can't tell how much torque you're putting down on the thing. So, you know, something to think about there anyways. But yeah, the shop press is pretty much done now. You know, it's foot operated, it's real easy to use. I'm happy with it. Okay, so here's my lathe drawer here, my lathe tooling drawer, and picked up some inserts from Inco. These are ISCAR TCMT 3-1 SMs, and IC3028 is the ISCAR part number. They're coated, and the reason I got them was originally I had these offshore brand interstate inserts, same kind of thing, same size and everything, but man, I'm telling you, the carbide stinks. It chips like crazy, doesn't last long, coating wears off. They're junk. I think I paid $5 a piece for them. These ISCARs were like 10. They're a million times better. So you get what you pay for. If you want an insert that's going to last and not chip on the first interrupted cut, it's got a PVD coatings on them. These work really well, and like I say, they're about twice as expensive, but they're worth the cash. So, word to the wise, I got some. I'm pretty much going towards ISCAR and everything. I've got my internal, external threading inserts as well, and they work quite well. That's kind of like what convinced me to get the ISCARs for the general turning. When I started threading with these, I was quite impressed with how well they worked. So, you know, next time I threw an order in, I mean, those 10 inserts here, this thing cost me $96, and that was on sale. So, you know, yep, they work good. Stick with the brand names. The interstate stuff may look good because it's cheap, but it's not worth it in the long run. You'll end up breaking most of them, and they'll cost you more in the long run. All right, so I got a little tip for you here. I keep a few Neo magnets around the shop. They got a couple really convenient uses. This is an N52 Neo magnet, and it's pretty powerful. One of the really useful things of this is how many people carry cell phones around in their shop. And the little speaker, I don't know if you can see that, the hole fills up with chips, because you get chips in your pocket. And the little magnet in here attracts them. How do you get them out, right? Well, the way I found is use a more powerful magnet. So right now, I know you can't see this, but this thing's full of chips. It looks like a Brillo pad inside of there. I don't think the camera's going to focus that close on it. But what you do is you take this magnet and you put it right on top of the speaker. And guess what? All that crap comes out of there. There it is right there. Okay? So there's a little tip for you. If you gotta get a cell phone full of metal chips and you can't get it out of the little hole, go out and get yourself a cheap Neo magnet. I mean, this thing's really strong, but it costs nothing. One of the other controversial things I'll mention is these things are great for taking splinters out. If you're cutting steel, like if you're side milling something and you're making all those little needles, you get one stuck in you and you can't dig it out with a pair of tweezers, Neo magnet will take it right out. And I hate to say this, but like if you ever get something in your eye that's magnetic and it's not dug into your cornea or something like that, this is the way to go. You know, forget the tissues, forget the blinking, forget the eye crap. Just put one of these next to your eye and open it. Suck the chip right out of there in 2 seconds. So that's a good use for Neo around the shop. Just keep it away from your milling machine and your lathe, because it'll quickly grow fuzz if there's metal around. So I stick it to the side of my toolbox, and when I need it, it's right there, and they work great. So there you go. Okay, let's talk abrasives. I have 2 grinders in this shop. This is a cheap Central Machinery, I think it's a half-horse grinder. Yeah, half-horse. And came with 2 silicon carbide wheels. This one was a coarse, I think it's 36 grit. And it came with a fine, which was I think a 50 or 56 or something like that. What I use this for is, on this side, I use this for rough grinding steel or rough grinding tool bits. It takes the stock off fast, and it works real good for getting it down to where you need it. And then over here, I've got an aluminum oxide wheel. And this is what I use to put a secondary finish on my tool bits. I never use this for rough grinding, it's too soft. I only use it for tool bits, high speed steel. And it works real good for putting a pretty good finish on it. You want to stick with aluminum oxide, in my opinion. I don't like silicon carbide. It works for fast stock removal, but it's brutal on the steel. I like aluminum oxide for grinding tool steel. So now we get over to this one. Now I've talked about this one in other videos. What I have on the left side of this one is green aluminum oxide, green silicon carbide wheel, and this is for grinding carbide. And I don't do much grinding of carbide. Basically, this grinder came with 2 green wheels on it. I left the best one on, and I replaced the other wheel with aluminum oxide. And this is what I use. This is a 100 grit aluminum oxide face wheel that I use to put the final finish on my tool bits. It works real good. Doesn't heat up the tool steel at all, really. I mean, unless you go crazy. But if you use the other grinder to get the profile, and then you use this just to touch it up, you can get real accurate clearance angles. And you know, I really don't even have to quench the thing. So you know, that's what we use here in the shop to grind our own tool bits. Now, I use two kinds of bits in my lathe and in my mill. I use high-speed steel and I use carbide inserts for the most part. You know, high-speed steel, obviously, you're sharpening it up all the time. The carbide, I don't even bother really sharpening the inserts, aside from just a little touch-up once in a while, which I'll show you how I do that. But you know, the jury's still out on the screen wheel. Not sure I'm ever going to have much use for it, but the machine came with it and it's on there. You know, maybe I'll play around with it a little bit and see what I can learn. So anyways, then that brings us to honing and stoning. And what I have here mostly are India stones for touching up tool bits. A little fine stuff. This one's good for end mills because it's got the rounded edges on it. Okay, and just a couple strokes with that, you can hone an edge back that's kind of getting dull. Now for carbide, I use these easy laps. I have a fine and a medium. Of course, it's kind of crazy. I'm not going to be like filing down inserts, but once in a while, you know, you need to just touch it up. So I use one of these diamond hones to do that. I have also used these on high-speed steel. There's a lot of controversy that I've seen on the net about saying using diamond stuff on tool steel because the carbon goes in there and it'll wreck up the the carbon will go in and wreck the matrix on the high-speed steel. I haven't really found that to be the case, and I do use those diamond laps on the tool steel, and it's never been a problem. So you know, if you want to do it, go ahead and do it. If not, don't. Okay, so as far as the manual abrasives go, I've settled on the roll-lock type thing for all the small stuff. I used to use the hook and loop, which is right there. As you can see by this backing pad right here, right out to the edge, a lot of the little hooks are missing. And this is what happens if you're not careful and you run off the edge of the work that you're trying to finish. Basically, it rubs on here and tears off all the little hooks. So that's kind of a bummer. You know, for the same amount of money, you can pick up a roll-lock arbor. And the great thing about that is if you screw up, you know, you blow the disc up or whatever, you can just replace it and you get a whole new mount for it. The backing plate doesn't hold it, it's the thread that holds it. So I have two kinds of abrasives that I use on my pneumatic tools here. This one is the 3M fiber type abrasive, and this is great for finishing up aluminum, like cleaning up the face of it after you machine it, just to get it like almost to a mirror finish. Not too aggressive, but they do a good job. These right here are the 3M Cubitrons, and these are really aggressive. These are sanding discs. I think they're about 100 grit, and man, if you want to take stock off, this is the way to go, because this stuff will take it right off. Now, as far as cutoff wheels go, I have a mandrel that will allow me to mount this wheel in my grinder as well. And these are alright. They're a little big for it, and they can only cut, you know, on the edge. They're cutoffs. They work okay. But what I've also got here is some 3M Cubitron, what do they say, green team on them or something like that, green core. These are ceramic based, and you can use them as cutoff wheels or, you know, face grinding. So this would be great for like slotting metal, cutting stuff, you know, cutting welds out, that kind of thing. I have yet to try these, but I will in the near future and let you know how they work out. So that's some of the hand abrasives I use here to finish metal as well. And I use them in these pneumatic tools. And finally, what I use in my 4-inch grinder, 4.5-inch grinder, is these depressed center DeWalt wheels. They thread right on, and they work really well. They're about 1/4 inch thick, and this is what I use for like putting weld bevels on steel and things like that. Alright, let's turn to lubes. What I use in my lathe spindle here, these two bearings, is mobile fluid 424, which is a synthetic hydraulic oil, and it works really well because my shop isn't heated in the winter time, and it can get really damn cold in here. Now I did, you know, put the machine heaters on here, and it keeps the machine, you know, reasonably warm, but the primary use of that heater is to keep this thing from rusting up. So, you know, I mean, if it's 0 degrees in here, you know, that oil is going to be 0 degrees pretty much, maybe a little hotter, but not much. So, you know, I went with a synthetic oil because of that. And the mobile fluid 424 meets all the requirements for the bearings that I have in here. There's tapered roller bearings in this lathe spindle. So that works out really well for me. As far as what I use for cutting oil, 90% of the time, it's this stuff right there. Thread cutting oil, sulfurized chlorinated thread cutting oil. I also have some Molly D, which stinks so bad that I tend to not use it because, I mean, you know, if I have something really tough to tap or whatever, I'll throw some of that on there, but you do not want a machine with Molly D because the smoke that comes off of that stuff is horrid. I also do use Relton Rapid Tap on occasion. I have the dark sulfur oil in this one, and I have the Rapid Tap in this one. Rapid Tap works okay for me. It does kind of stink as well, but it works just as good, if not better, than the thread cutting oil. So I use that. On aluminum, I use the Winbro Tap Free or WD-40. Either one of those seems to work equally well. You know, for aluminum or non-ferrous stuff, brass, whatever, that stuff works good. I got some Croyle. That's mostly, I don't use that for anything other than trying to loosen bolts and stuff like that. I don't use that for cutting fluid or anything. In this simple green container, I have mixed up a water-based coolant. For the life of me, I can't even remember what it is. Somebody gave me a bottle of it 10 years ago, and I just got around to starting to play with it. So I think it's more of a coolant than a lubricant. It does have some kind of lubrication properties in it, but you know, the jury's still out on this. I gotta weigh the options of whether the mess that this creates is worth the cooling action that it provides. So this is kind of like an experiment in progress. And finally, we have Rely On. You know, what can you say about it? It works. I don't use it too much, but you know, in certain applications it comes in handy. I primarily use it on ferrous metals. I do not use it on non-ferrous. Non-ferrous stuff is tap-free or WD-40. So those are my cutting oils. And what I use for whey oil is Mobile Vactra. Number 2 is the thickness that I find convenient for this lathe. It's not too goopy in the winter, and it's not too thin in the summer. And you buy a gallon, I think it costs less than 20 bucks for a gallon. It'll last you forever. I have my Eagle pump oiler, and that's what there's Vactra in this. And this is how I do my whey oiling. This little ball tip here fits real good. I use this on the milling machine and the lathe. Inject the whey oil right in there, and then I also do stuff like that. And that keeps the machinery happy. What else can you say about lubes? I'm sure there's a treatise out there somewhere, but I don't have it for you. But that's just what I use here in the shop. You've seen, you know, when you use that dark sulfur oil, it makes a hell of a lot of smoke, and that's what this thing comes in for. This here is hooked up to the suck pump. I got a pipe going over to here. This is on a gooseneck, and if I position it just right, it'll follow the carriage up like that, and sucks out almost all the smoke, except when I got something really big in the chuck and the jaws are hanging way out. It kind of acts like a fan, and then this thing is not as effective. If I have a collet in there, or if the chuck is small like it is here, you know, if I'm holding something small, it works real good. Sucks all the smoke out, keeps me from choking. You know, I used to have to open the door, but now that I got the AC, you know, you can fill this room up pretty quick with smoke that will choke you. So it's good to have some kind of fume extraction. And you know, I have the same thing here. This is the other end of the other pipe, held on, of course, by a neo magnet. And I can stick this wherever I need to. With a milling cutter, it doesn't create any turbulence, so this thing sucks everything right out of there. It can be right next to the cutter, sucks it right out, no problem. That's about it, I guess. Let's see what's on the list here. Oh yeah, the sign bar. Hang on, let me set that up and I'll show you what I'm talking about with that. Okay, so I tried to frame this so you could see it. Yeah, I haven't had a sign bar, but after watching, you know, Tom on Ox Tools and stuff like that, I kind of guilted me into getting one, because you can do a lot of things with them. Now, this one's brand new. I haven't even cleaned the schmeg off it from China, but it's a 5-inch sign bar, and it's pretty nice. Now, this surface that I'm on here is a concrete fake of a granite countertop. It's flat. It's not like a surface plate, but it's flat enough. I mean, for the kinds of precision stuff that I'm doing here, this thing's fine, you know. I mean, I can't really measure any weirdness in the thing. I think when they poured it, you know, it's self-leveled by gravity, so the top is pretty flat. It's got a few divots and a few scratches, but you know, it's a poor man's surface plate. What can you say? Now, most people with these sign bars, they go out and they get step blocks or whatever to set the angle on it. But what my idea was, well, I thought of it, but I'm sure I didn't invent it, but I thought this up, is you get these adjustable parallels. And I can find a screwdriver that fits it. Oh, there's one. The way these work is they slide. So you can set the height, you know, to anything that you want. So, you know, just for giggles here, this is a 5-inch sine bar. If I wanted a 45-degree angle, you know, I'd have to jack this up, you know, 5 inches. I can't do the math in my head. I need a calculator, but you know, what you would do is you would calculate the step block height that you would need for a given angle here. And you know, it's just 5 times the sine of the angle. Okay, and then you set the step block to whatever, you know, your desired height would be. And then when you put it on the sine bar, guess what? You get your angle. Not as convenient as step blocks, not as accurate as step blocks, but it's a poor man's way of getting a pretty accurate angle in the shop. So I have a bunch of these little Starrett adjustable parallels. Let me get some more and show you. Like everything else I tend to pick up that's decent quality is, you know, these came from an estate sale, and they're all Starretts. I don't even, you know, they came in a bucket. I don't even know what I paid for them because, you know, most of the places I go, they're like, yeah, just get them out of here. We don't want them. So they don't know what they have, but these things are really nice. I got a set. A nice set here. Here's another set. Get some crud on this. Here's another. And another. And then I got one mongrel. But these things come in real handy. I mean, you know, for years I had these things and I didn't know what to do with them. And, you know, the more I watch Tom on Ox Tools, the more amazing stuff he comes up with for, you know, the uses for these things. One of the very first things that he taught me is you can use them to measure widths of keyways. For example, hang on, let me pause the video and move the camera. Okay, so I got this from Tom Lipton. Basically, you want to measure the keyway. You can use an adjustable parallel because what this does, it will act like a key and ride on the high spots. Okay, and then you take this and you tap it in there and you snug it up, and then you can put your dial calipers on here. It'll give you a real accurate measurement of what the width of the slot is, so you can make a key for it. Just another thing that you can do. Alright, that's about all I got to say for this one. I'll hopefully come up with some more videos pretty soon, but those are some of the things I thought about while I was staring up at the ceiling last week. So have a good one. Thanks for watching. Hope you picked up something from this, and if you like it, subscribe, and hopefully we'll come up with some more good stuff for you. Thanks for watching.